Thank you very much. Now for something a little different. Modern medical imaging has transformed healthcare and now plays a critical role in the diagnosis and treatment of virtually all significant medical conditions. Unfortunately, there's a growing shortage due to increased utilization and other factors of qualified radiologist physicians that are necessary to interpret these imaging studies. And when they do interpret them, there is a small but significant error rate in the interpretations that contributes to human error as being the third leading cause of death in the healthcare system behind cardiovascular disease and cancer. Finally, the high cost of these interpretations limits this potentially life-saving technology, and limits access to this potentially life-saving technology from those who need it most. In 2012, there was an amazing breakthrough in a field of artificial intelligence, specifically the use of neural networks in a field called deep learning. For the very first time, computer programs were able to surpass human beings in the ability to perform certain complex visual recognition tasks. In response to this, we formed a company to look into the application of deep learning techniques to what may be the ultimate complex visual recognition task, that is medical imaging, interpretation, and diagnosis. To do this, we formed a world-class team of experts in radiology as well as thought leaders in computer science. We were fortunate to have Jan LeCun join us. Jan is recognized as the inventor of deep learning technology. His daytime job is he serves as artificial intelligence director at one of the largest artificial intelligence companies in the world, known as Facebook. In addition, we raised millions of dollars in venture capital fund. We assembled a database of upwards of 1 billion medical images, and then began to apply the technology to use deep learning to recognize these images. In December 2017, we released a paper which for the first time showed our software interpreting CT scan images of the head with greater accuracy than was possible with human radiologists. This software was created using over 9 million images of CT scans of the head. This is what it looks like. On the right is a CT scan of the head. Most of you know will recognize it's a slice through the head, an axial image there, and down on the side there is an abnormality that a human radiologist is able to detect typically in about 300 seconds or 5 minutes to see that abnormality and process all the multiple images in the stack for the CT scan of the head. Our system can recognize the same thing in under 1 second. The humans, as discussed, have a very low error rate in reading these, but our system has an even lower error rate. And finally, the cost. In the United States, an average cost for an interpretation of this sort is about $50 US. For our system to do it, because it runs in software, it costs about 0.2 cents to do the same thing. For blockchain, smart contracts, and utility tokens, we now see this as a way to further lower the cost and add further efficiencies to our system. In particular, as we expand into international markets and doing foreign currency conversions, we're going to offer our services with utility tokens as a lower price than the fiat currency, and thus pass these savings on to our customers and also create value in the tokens. In medical imaging, in healthcare, there's a great expense associated with fee processing, collections, accounts receivable. By using smart contracts and automated payments with utility tokens, we can eliminate these and again offer utility token payments at a lower price than regular currency prices, and pass those on to our customers as well. incentivizing the deep radiology community of developers, physicians, patients, and other people who just think the technology is cool, rather than using Visa or MasterCard or wires or checks to pay them. By using utility tokens, it gives us greater flexibility and actually using micropayments to incentivize them. Then finally, neural network processing requires great amounts of graphical processing units, GPUs. We actually use the same type of GPUs that are used to mine cryptocurrencies like Ethereum. Instead of making payments to large cloud providers for GPUs like Microsoft or Google or AWS or our local data farms, instead what we propose to do is move the processing onto the blockchain and allow our deep radiology community to mine and provide processing power, and thus the money goes to them instead of these legacy firms. And in doing so, by having distributed processing, we also, as most of you know, will increase the security of this confidential medical information and also the reliability beyond what's available from the blockchain providers. So we're very excited about using two of the most transformational technologies of the 21st century, that is deep learning, artificial intelligence, and blockchain and smart contracts, to lower the cost of medical care and make this technology available to those who haven't been able to access medical care before. If you like what you hear today, please join us on our journey to change the world. Thank you.